Now, having seen the effect of truncation psi on the generated output, in this next set of experiments, we will analyze the effect of mix after on style mixing. In style mixing, the key idea is to make use of two latent vectors instead of one latent vector and show that the images generated using the two latent vectors has components of the images generated using those corresponding latent vectors alone. The value of mix after, which is set here, is effectively the serial number of the block in the synthesis network after which we start using the second latent vector. If this is unclear to you, I would highly recommend you to watch a previous style GAN2 Colab demo video that I had mentioned earlier in the video, the link to which you can also find in the video description. Now in this next part of the video, I will demonstrate how mix after controls the amount of style mixing. So let us start the mix after analysis with the CAD dataset. Let us not change any other parameters to have an initial idea of how the style mixing looks with the set of default values of these parameters. We run this cell to save the parameter values and run the following cell to generate the style mixing output. So as I mentioned before, we will have to make sure that the resolution is set correctly. Now the generation takes some time as we are generating comparatively high number of high resolution images. Now we have the results. The first latent vector alone generates the image on the left, while the second latent vector generates these images on the top row. The bottom row images are obtained by style mixing, and we can clearly see that they have components of the left image and the corresponding top row images. In fact, you can see that all cats in the bottom row have the same structure, pose and type as the cat on the left image, while the fur color and background style is similar to the cats on the top row images. Now let us change mix after to see how this trend changes. Now in the style GAN2 paper, the authors state that the initial layers of the synthesis network controls features such as pose, general shape and things like that, while the latter layers control finer features such as the color of different elements in the image. So what we expect is that on increasing mix after, we are delaying the use of the second latent vector, and hence the images generated via style mixing should have more features similar to that of the image on the left. Similarly, on decreasing mix after, we expect the mixing results to have more features from the top row images than the current results. Now let us change the value of mix after and see if the results agree with the aforementioned logic. Let us increase the value of mix after to 10. We can do that using this slider. We run this cell to save the values, and we will now look at the generated results. And now you can see that the images generated from style mixing are more similar to the image on the left. In fact, the fur color shows very little variation, and only the elements of background have some resemblance to the images on the top row. Now let us decrease mix after and see how the results change. So we decrease it to 4. Now we can notice two major differences. The first, not only do we see the same background image of the top row images in the style mixing results, but we can also see that the background texture of the top row images have been translated in the style mixing results. The second major difference is that the transfer of fur color from the top row images is much more clearly evident in these results. We can see that the shape and pose of the left image cat are still retained. Let us further decrease the mix after value to see if the pose and structure also start to change for a reduced mix after value. So we set mix after to 2 and check the results. Now we can see that the pose and shape is no longer the same as that of the cat in the left image. Moreover, the eyes and ears and other features also seem to be in between those of the left image cat and the corresponding top row image cats. So we get somewhat of an interpolation of features on changing the value of mix after. So let us try this with the car dataset. Now, as we already downloaded the pre-trained weight for the car dataset earlier, we can just simply load those weights by calling the nn.load parameters function in a code cell and specifying the path to the pre-trained weights for the car dataset. So we just add a code cell here and call the nn.load parameter. Now we run this cell to load those weights, and we have done that. We also need to change the resolution argument in the generator function call as we did earlier. Cars are generated at a higher resolution of 512 cross 512. So after that, now let us start by checking the results for a value of mix after as 2. We'll run this cell again to save the value. Now let us run this cell again. So here we have the results. Now we can see that the pose of the car on the left image has changed to match the pose of the cars on the top row images. The background also shows significant deviation. Wheels of the bottom row cars also seem to match that of the top row images, while the shape of the car has common elements with the left image car as well as the corresponding top row image car. Now let us change the mix after value to see how the results change. So we set mix after to 6. We run this cell again and we generate the results. Now we see that all the images in the bottom row have the same shape and parking orientation. Color of the car is coming from the corresponding top row image, and the background has common elements from the corresponding top row image as well as the left image. As before, let us further increase mix after to check the results. So let us set mix after to 8 this time, and we run the two cells to generate the results. Now we can see that the color of the car is a mixture of the color of the left image car as well as the top row image car. Let us increase the value of mix after to 10 this time. Now we see that the color comes entirely from the left image car and not from the top row image car at all. In fact, what we can observe now is that the top row image cars are only causing minor modifications in background. So using mix after value, we were able to interpolate the color of the car with mix after equal to 6 resulting in color coming from the top row images, while mix after equal to 10 resulting in color coming from the left image cars. So after this, let us try style mixing on faces dataset. Style GAN2 is best known for its results on the task of human face generation. So I think style mixing with human faces will be the most interesting case to see. So first, let us load the pre-trained weights for the human faces style GAN2 model. So now we have loaded the weights corresponding to the style GAN2 generator that can generate human faces. Now this time let us start with a really high value of mix after, say equal to 12. Now we run the cell to save the parameters and generate the results. Of course, before that we must change the value of resolution. Having done that, we run this cell. So what we can see is that the basic look of the face, including facial features, pose, expressions and all, are same in all the bottom row images. The illumination of the image seems to be coming from the top row images. On reducing mix after, we expect to see more of the top row images in the style mixing results. So let us try that. Now we'll set a value of mix after to 9 and generate the results. So for mix after equal to 9, the basic look of the face and pose are still the same, but we can see a noticeable similarity of skin color in the top row images and the style mixing results. Now there is a slight variation in the hair color as well, but skin color seems to be the major difference in the different style mixed faces. Let us further reduce the mix after value to say 6 this time. We generate the results. Now we can see some more differences. First, the background has similar colors to the background in the top row images. Second, not only the skin color but skin texture including wrinkles are coming from the images on the top row. Third, also the hair color of the style mixed faces is coming from the images in the top row. Now let us set mix value equal to 4 and see the results again. Interesting. Now what we can observe is that the identities of the face in the bottom row is no longer consistent with the left image face identity. The facial features comprise features from both the left image as well as the top row images. Another interesting observation is that the background texture of the top row images can now be observed in the style mixing results. Now let us further reduce mix after to a value of 2 and see how the result varies. Now what we can see is that the face identity is nearly same as that in the top row images, while only the pose of the style mixed faces is same as that of the left image. So what we can deduce from these results is that the first two blocks of the synthesis network, which synthesize the 4x4 image, broadly captures the pose and some elements of hairstyle. As the identity of the faces were fixed for a value of mix after greater than 6, we can also conclude that the facial identity or the basic look of the face is captured by blocks 3 to 6 of the synthesis network, while skin color, hair color, image illumination, and some of the minor background changes are captured by the latter blocks of the synthesis network. These observations are very consistent with what the authors report in the original style GAN2 paper. Now, in this similar manner, you can try out and play around with style mixing for other types of data as well, where you can vary the amount of style mixing and observe what is being captured by the different blocks of the synthesis network of style GAN2. I hope you enjoyed this video on analysis of style GAN2 generation. Thank you so much for watching. Please subscribe to our channel.